So the very next topic is common mode rejection ratio, right? So basically they can ask you the definition of common mode rejection ratio, or they can ask you the formula based on that, that is V naught is equal to AD VD plus AC VC. Okay, what is AD? AD is the differential gain. AD is the differential gain. VD is the difference in the voltage. Okay, like difference in the voltage, suppose we'll have two voltage. We'll have the voltage like this. One of the voltage is V1, another of the voltage is V2. So it would be V1 minus V2 is equal to VD. Okay. Then AC is what? AC is the common mode gain, and VC is the basically mean voltage. So VC is basically V1 plus V2 divided by 2. So now you have to learn this formula, and if you need to calculate in decibels, you need to multiply it by 20 log that formula. Suppose I am teaching you one question based on that. That is from your paper only, question number 16. Define CMRR. You need to learn the define. Define is present in the notes which I send it to you. That was for the Opamp. Remember? Okay, they said V1 is equal to 0.25 millivolt and V2 is equal to 0.25 millivolt, and the output voltage is 4 volt. For the same Opamp, in the another case they said V1 is equal to 0.5 millivolt and V2 is equal to 0.5 millivolt, and the output voltage V0 is equal to 6 millivolt. Now you need to calculate CMRR. Try to do it by your own, then I'll tell you. In this case, write down one more formula for CMRR. Like CMRR is how much? AD by ACM. If you don't need any unit, but if you want CMRR in decibels, then for that CMRR in form of decibels, it would be 20 log base 10 AD by ACM. Okay. So in this question, basically you need to calculate the value for AD and AC. In some books it is denoted by AC, and in some books it is denoted by ACM. ACM is what? Common mode gain. Okay. So V voltage they already give it. V1 is given and V2 is given. Right? Now do it. Okay, now C will have formula V0 is equal to AD VD, right, plus AC VC. So let's consider the first case. V0 is 4, right? AD we don't know. VD is, as I told you, the difference in the two voltage, 0.25 minus, one second, I think it's they have given us minus 0.25, just corrected, not plus, it's minus only. Okay, so what is VD? As you have calculated separately, then VD is V1 minus V2, right? So V1 minus V2 means 0.525 minus of minus 0.25, correct? Plus AC we don't know. VC is V1 plus V2 divided by 2, right? It would be 0.25 minus 0.25 divided by 2, correct? So if you'll solve it further, now tell me the equation. After solving, what we will get? Then we'll get AD is equal to 0.5. It's in milli. That would be 10 raised to power minus 3, correct? This will become 0. So from here we'll get the value of AD, that will get it as 8 into 10 raised to power 3. Correct? Now similarly for the second case, apply the same equation. But this time V1 is 0.5, V2 is 0.5 and V0 is 6 millivolt. Do it the same pattern. Correct? Now after solving you will get AC as 12, right? But in the question they don't ask us AD and AC, but they have asked MRR. Okay, so as I told you the formula, that is by AC. If you want to calculate CMRR in decibels, then in that case it would be 20 log AD by AC. Do it by the both the method. Tell me for this value and tell me for this value. Next, the formula based on diode current equation is ID is equal to IS e raised to power V divided by eta e minus 1. Okay, you need to remember this formula. I think I don't remember whether this formula is given in your handbook or not. Like suppose this is the diode, ID is the diode current which is flowing in the diode, IS is the reverse saturation current. Okay, IS is the reverse saturation current, or they can ask you the current flowing due to the minority carriers. VD is the applied voltage across diode. Okay, eta is the, you remember what is eta? Eta is the basically ideality factor, non-ideality factor. Its value is fixed. If they said silicon, its value is 2. If they said germanium, its value is 1. Okay, and Vt is the thermal voltage. So we'll have particular formula for Vt, that is Kt divided by Q. K is the Boltzmann constant, T is the temperature, Q is the charge on electron. So K value is fixed, that is 1.38 into 10 raised to power minus 23 per Kelvin. Charge on the electron is also fixed, 1.6 into 10 raised to power minus 19 coulomb. And if temperature they have given as room temperature they generally consider as 26 millivolt. Room temperature they generally consider as 27 degrees Celsius, right? So this temperature we need to take it in Kelvin. This temperature we need to consider it in Kelvin. So it would be, if I'll put all the values like 1.38 into 10 raised to power minus 23 multiplied by, do you know how to convert that Celsius temperature into the Kelvin? By adding 273. So that will be 300 Kelvin. So 300 divided by charge is 1.6 into 10 raised to power minus 19. If we'll solve it, then you will get it as 26 millivolt. So basically you need to remember it that Vt value is fixed, that is 26 millivolt for room temperature, because 90% of the time they ask you the room temperature. So instead of wasting your time in calculation, it's better to remember this value, that at room temperature Vt is thermal voltage is 26 millivolt. But if they have given any another temperature, then in that case you need to put that value. Okay, question number 15 from your paper only. They said it's a germanium diode. Okay, and that carries a current is how much? 10 milliampere, means basically it's a diode current. When a forward biasing is forward bias. Okay, when the forward bias is given, then we'll take voltage as positive. If the reverse bias is given, then we'll take voltage as negative. Got it? Applied at room temperature, they said temperature is 27 degrees Celsius. and first part they ask you to calculate reverse saturation current. Okay, so reverse saturation current means IS, right? Now calculate the value of IS.